Hello viewers. Welcome to the YouTube channel Smart Tricks for Study. In this video, we will see important Physics Chapter 1, that is, Electric Charges and Fields, formula for NEET and CET entrance exams. Last formula is very important. So watch till end. Just do like and subscribe the channel. If you want PDF, just comment PDF. Let's start one by one. 1. Quantization of charge. Q is equal to Ne, where N is equal to number of electrons added or removed from the body. Q is equal to charge on a body. E is equal to elementary charge. 2. Coulomb's law. It states that the force between two-point charges is directly proportional to the product of magnitudes of two charges and inversely proportional to square of the distance between them. The force is acting along the line joining two charges. For vacuum, vector F is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R square into R cap. For medium, vector F is equal to 1 by 4 pi epsilon naught, epsilon r, into Q1 Q2 by R square, into R cap. 3. Electric field intensity. E is equal to F by Q, where Q is equal to source charge. Q naught is equal to test charge. 4. Electric field due to point charge. Vector E is equal to K into Q by R square into R cap, where K is equal to 1 by 4 pi epsilon naught. This graph indicates E is inversely proportional to R. 5. Electric flux. For uniform electric flux, phi is equal to vector E, A is equal to EA cos theta. For non-uniform electric flux, phi is equal to integral of vector E, dA. For closed surface, phi is equal to closed integral of vector E, dA. 6. Electric field due to dipole. 1. At an axial point, vector E is equal to 2, K, P by R cube. Here, P and E in same direction. 2. On equatorial line, vector E is equal to K, P by R cube. Here, P and E in opposite direction. 3. At any general point, vector E is equal to K, P by R cube, into square root of 1 plus 3, cos theta. 7. Electric charge due to conducting sphere. 1. EC is equal to K, Q by R square, if R greater than capital R. 2. EC is equal to K, Q by R square, if R is equal to capital R. 3. E is equal to 0, if R lesser than capital R. 8. Gauss's law. Phi is equal to closed integral of vector E, dA, is equal to Q by epsilon naught, where Q is net charge enclosed by the closed surface. 9. Dipole moment, P. P is equal to modulus of plus or minus Q to A. 10. Dipole placed in uniform electric field. Torque. Τ is equal to P into E. Net force is equal to 0. F is equal to square root of F1 square plus F2 square plus 2 F1 F2 cos theta. Work done in rotation of dipole. U is equal to PE into bracket cos theta 1 minus cos theta 2. Electrostatic potential energy. U is equal to minus P, E. 11. Charge density. 1. Linear charge density. Lambda is equal to Q by L. 2. Surface charge density. Sigma is equal to Q by A. 3. Surface charge density, ρ is equal to Q by V. 12. Electric field due to infinite sheet of charge. E is equal to sigma by, to epsilon naught, into n cap. 13. Electric field due to infinite long charged wire. E is equal to lambda by, to pi epsilon naught r. 14. Electric field due to a solid sphere of uniform charge density and radius r. 1. E is equal to 1 by 4 pi epsilon naught, into Q by r square. If r greater than capital R. 2. E is equal to 1 by 4 pi epsilon naught, into Q by r cube. If r lesser than capital R. 3. E is equal to 1 by 4 pi epsilon naught, into Q by capital R square. If r is equal to capital R. This ends some important formulas from Chapter 1. Don't forget to subscribe the channel for more updates.